Okay, everyone, today we'll start with the trigonometry unit. And even as you see from this picture that you'll see on the very first slide, the trigonometry unit deal mostly with the right angle triangle and finding the sides, and or that was the start of the trigonometry unit. And then later on, it evolves into uh, non-right angle triangle. But today's lesson is mostly a review from Math and C. And on what you did on Math and C is you described the relationship between the angles and sides on the right angled triangle. When we are saying the right angle triangle, we mean that one of the angles in the right angle triangle is 90 degrees. And the way that we say that we assign that this is a right angle triangle is with this little square that you see on those two pictures here. And then the other sides, or the sides of the right angle triangle, are dependent on the uh, angle that you are sitting on, let's say. So if on the first triangle here we have this angle theta that we are looking at, the side that is opposite to the angle theta, it's called the opposite side, and the one that is supporting the angle is called the adjacent. It is kind of placing your eye here, and where your eye sees, what is the side that your eye sees first, and this will be the opposite side, and what is the side that the angle is supported will be adjacent side. And the hypotenuse actually is the side that never changes in the right angle triangle. So if we have the same triangle, and now instead of the angle theta that we have here on the side, we deal with the second acute angle here, then uh, it's, as I said, placing your eye here, and what your eye sees is named as the opposite side, and what the angle is supported, it's called the adjacent. And hypotenuse doesn't change, and in both scenarios that you see here, because it is always opposite to the 90-degree angle. So you most likely remember what SOHCAHTOA is. It is calculating the angle or the sides when we know the sine, cosine, and tangent, or calculating sine, cosine, tangent. So the SOHCAHTOA definition, or the way that we remember it, is because sine is calculated as opposite over hypotenuse, so it's the ratio between opposite and hypotenuse. Cosine is the adjacent over hypotenuse, and tangent is opposite over adjacent. Now let's see those examples that we have here, another slide in which we are naming labeling the sides of the right angle triangle. So just for simplicity, what I will do is I will label the triangle A, B, and C, and then we will see that what we are dealing with is a right angle triangle, and angle B is labeled as angle theta. So if you place your eye here, what you see as the opposite of the angle is of the side AC. So this will be the opposite. And what do you see here as the angle is supported is the side BC. So this will be adjacent. And opposite to the right angle is the hypotenuse. If we move to the other triangle, again, I will label it for simplicity A, B, C. And then we will see that the angle that we are dealing with is angle A on this case. So if you can start any way you want, you can say that, okay, this is the hypotenuse since it is opposite to the right angle triangle, and now you have to label the other two sides. So opposite of angle A is side BC, and this will be the opposite side, and angle AC is the adjacent where the angle is supported, and this is the adjacent side. Now, with the sides already labeled, let's see where is the angle theta that we are discussing. So now we are going backwards. On the first example, we had to label the sides, and now the sides are labeled, and we will see the angle. So on the first example that we have here, hypotenuse is always opposite to 90 degrees, and opposite of the opposite side, we have this angle here, and this will be angle theta. And now we double check. The angle theta has as an opposing side this side that is named as the opposite, and as the adjacent where it is supported is the adjacent side. Now, next one, again, the hypotenuse is opposite of the 90-degree angle, and the angle that is opposite to the opposite side is the angle theta that we are looking for. And even on this side, you can see that this angle theta is looking at the opposite side and is supported by the adjacent side. Now, the other thing that you have seen on Math and C is that it is known as the Pythagorean theorem, which is a squared plus b squared equals to c squared, where a and b are the sides, the shortest sides of the right angle triangle, or adjacent and opposite side of that, and c is the hypotenuse. So now, in this triangle that is given here, SRT, where the opposite the hypotenuse is 25, and the one of the sides is 7. So now we are looking for what is sine of angle R, cosine of angle R, tangent on angle R, and the same thing for angle S. But before we do this, in order to use the SOHCAHTOA, we need to find the third side of the right angle triangle, which is missing here, and it is side ST. And in order to do that, what we will do is we will find using the Pythagorean theorem, which is a squared plus b squared equal to c squared. So if we substitute a and b can be, you can switch, it doesn't really matter. 7 squared plus b squared is equal to 25 squared. And now the way that we solve it is using simply the calculator. So 7 squared, oops, 7 squared is 49, and 25 squared is 625. So then what we have here is, where are we? What we have here is 49 plus b squared is equal to 625, and then from here we find that b is equal to, let's do this calculation, 625 minus 49 and then the square root of the answer. And it is 24. So the side that we are looking for is 24. Now that we have all three sides of the right angle triangle, we can work on finding the sine, cosine, and tangent of angle R first, and then move to angle T. So for sine of angle R, so you are standing here on this angle R here, and what do you have? Angle or side ST is the opposite, okay, opposite, and side RT is the adjacent. And of course, hypotenuse, as we said, it doesn't change on a specific right angle triangle. It's always the 25. So for sine, what we have based on the SOHCAHTOA, we have opposite over hypotenuse, which means that the opposite of angle R is the length of ST over RS. We just found the length of ST, which is 24, and the length of the hypotenuse is given over 25. So this is the sine of angle R. Now cosine will be adjacent over hypotenuse, because so CAHTOA, then this will be 7, or the adjacent of angle R is RT, and the hypotenuse is always RS. So the answer will be 7 out of 25. For tangent is opposite over adjacent. And the opposite of angle R is ST, and adjacent is RT, which means that the tangent of angle R will be 24 over 7. For angle S, which is this angle here, we'll use the same logic. So we'll go sine of angle S will be opposite of angle S over hypotenuse. And the opposite of angle S is RT. And the hypotenuse is always RS. So this will be 7 out of 25. And cosine of angle S will be adjacent of angle S over hypotenuse, which adjacent of angle S is the length of ST over hypotenuse, always RS. And this will be 24 out of 25. And for tangent of angle S will be opposite of angle S over adjacent of angle S. And opposite of angle S is RT, and adjacent is ST, or in numbers will be 7 out of 24. I hope that this makes sense and it brings your memories back. Now, when we are solving for the unknown angle, what we will do is we will use that is known as the inverse Trig ratio. I will show you in the calculator. So now we use all three ratios to solve the missing angle. So missing angle is this one. One we will use one of the three. Doesn't really matter which one. We'll use one of the three. So now, when we look at this angle theta, the length 4, just for simplicity, again, I will put some letters here. So this will be A, B, and C. The length BC will be 4, and which is 4, will be the opposite, and the hypotenuse AB will be 5. You can go ahead and figure out the other side, but we are looking for the specific angle. So the ratio, trig ratio that relates those two sides, remember, so ka toa is opposite and hypotenuse. So opposite and hypotenuse of this angle. So sine of angle theta will be opposite, which is BC, over hypotenuse, which is AB, or will be 4 out of 5 over 5, a ratio of 4 over 5. In order to find the angle theta, what we will do is we'll use that is known as the inverse sine or inverse trig ratio of the sine in this case. And in order to do that, what we will do is we will use the calculator. So inverse is reached by pressing second function sine, and then we say 4 over 5. Enter, and then, oh, yeah, what do we see here in the calculator? This is a good opportunity to tackle what do we see here in the calculator is 0.92729 and so on. But this number is when the angle in radian. In order to move to degree, because this is what we usually use, is we'll go to the mode of the calculator. So we press mode, and then we go to radian. We choose degree, and then see that it is flashing. Okay, so now we quit from here, and we press again second function sine 4 over 5, enter, and the angle is 53.1. Okay, so the angle is 53.1 degrees. Okay. Now let's take a look at the other one when we have to solve for the unknown side. So we have the angle and we have one of the sides. Now, before we move to finding the side, we have to label the side. So the side that is opposite to the angle is the x. So this side here will be the opposite side, and the other side will be adjacent. So the trig ratio that relates, so katoa, that relates the two sides that we are dealing with is tangent. So tangent is, so katoa, let me change this into something else. The tangent is opposite and adjacent. So then we'll have tangent 36 degrees is equal to opposite over adjacent. Now we will solve for x. So this is x is equal to 9 times tangent 36. Always make sure that the mode of your calculator is on degrees. Don't make the mistake that I did when I found on the first one here. So now we go 9 times tangent 36 degrees. Enter. And then we'll have the side as 6.54. It's good to say. So x is 6.54. And if we are looking for the hypotenuse, then we can either use cosine or a squared plus b squared equals 2c squared. Let's move now to the next one. So the next example that you see here is this angle is given as 27 degrees, and the side that is opposite to the angle is 17. So that makes the 17 the opposite side. And the side that is opposite to 90 degree, it's the hypotenuse. So now, remember, so ka toa, the ratio that relates opposite and hypotenuse is sine. So then we will write it as sine 27 degrees is equal to opposite over hypotenuse, so 17 over y. From here, we find that y is equal to 17 over sine 27 degrees. And then we reach to our calculator, and let's clear this so that you can see. 17 divided by sine 27. Enter. And it is 37.4. So 37.4 units, whatever the units are. Okay, excuse my dog because he was barking. Now the next one is the right angle triangle, in which again the hypotenuse is unknown and one angle is 12 and one of the sides is 23. So this side is supporting the angle, which makes this side to be an adjacent, and the side that we are looking for is the hypotenuse. So again, if you look at the ratios, so katoa, the ratio, the trig ratio that relates adjacent and hypotenuse is cosine, then we will write it as cosine 12 degrees is equal to 23 over z. From here, solving it, z will be 23 over cosine 12 degrees. So now we reach to our calculator again, and we go, what was it, 23 divided by cosine 12. And it is 23.5. 23.5. Just to keep in mind, the hypotenuse is the longest side of the right angle triangle. So when you see that the hypotenuse is less, then you have to check most likely the mode of your calculator. Now, the other thing that is important on the trigonometry is solving the word problems, because believe it or not, trigonometry was used in Greek, like ancient Greeks, and they were finding those relationships because they had the need to build the buildings. And if you see, their buildings are right angle triangles, and the stairs and everything is right angle triangle. Okay, let's take a look now. The angle of elevation to the top of the school's flag pole is 62 degrees. The distance from the base of the flagpole is, the distance from the base is 14 meters. How tall is the flagpole? Always when you see word problems in general, what do you have to do is you have to translate the word problem into a picture, because this is what you are used to. Pictures are easy to figure out. So if this is the pole, the flagpole of the school, so if this is the pole, then what we are looking for, or no, not what we are looking for, but, and you are placed 14 meters from the base, then the angle of elevation, the angle that you see top of the pole, is 62 degrees. This is what it is saying. Okay. Now they are asking you how tall is the pole? So let's, in this right angle triangle, because we are assuming that the pole is at 90 degrees, that in this right angle triangle, the 14 is the adjacent side, okay, because it is supported to, is supporting the 62 degrees, and the pole, the length of the pole, the height of the pole is the opposite side, because it is opposite to 62 degrees. Now, when we have SOHCAHTOA, the ratio that relates two sides that we are dealing with, the adjacent and opposite, is tangent. So then tangent 62 degrees is equal to the height of the pole, flagpole, and over 14. From here, we find that x is 14 times tangent 62 degrees. And again, it is important to know that the mode of your calculator is on degrees, and you will type 14 times tangent 62 degrees, and you will have 26.3. Equals to 26.3 meters. So the height of the flagpole of your school is 26.3 meters. This is a bit more complicated. Now we have two buildings are apart 80 meters. So we have started the picture here. We'll just add the information on the picture as we are reading the question. So this is 80 meters. From a point halfway between between those two, so a point here, halfway, point P, which is 40 and 40, halfway means dividing it in two. The angle of elevation to one building is 72 degrees, and the other angle is 64 degrees. So now it doesn't really matter which one is the one that is 64 or 72, but the tallest one will have the highest angle. So this angle here, change the color, is 64 degrees, and the other one is 72 degrees, this angle here. Now, how much taller is the taller building? So we'll find the height of the first building and then the height of the second building and subtract the two together. So I will call this building 1 and this building 2. Let's find the first one. So now we have the side here. If we label them P, A, B, P, C, D. So if we label them, PA will be 40 meters, and we are looking for AB. So in the AB, in this triangle here, PAB, the AB is the opposite, and AP is adjacent. So what is that ratio that relates both two sides, adjacent and opposite? Leave it up to you to answer. Okay, hopefully you have said tangent. So tangent 64 degrees is equal to opposite over adjacent. And then we will have opposite, which is x, and adjacent, which is 40. From here, we find that the height of building 2 is 40 times tangent 64. And using the calculator, we'll go 40 times tangent 64, making sure that the mode of your calculator is on degree. This will be 82.0 meters. And let's use a different color. Now we are dealing on the triangle PDC, triangle PDC. In this triangle, what we have is PC is 40 meters and the angle P is 72. And we are looking for the side CD. So on this triangle, the side CD is the opposite side and the side PC is the adjacent side. The trig ratio that relates the two, it's again tangent. So we'll have tangent 72 degrees is equal to, what is it? Y over 40, which after you use the calculator, we'll figure out that Y is 40 times tangent 72. It is 123 meters. The difference between the two, because this is what we are looking for, how much taller is the taller building. The difference between the two will be 123 minus 82, and it is 123 minus 82, 41 meters. So the tallest building is 41 meters taller than the shorter one. Okay. Next one is two buildings that are 40 meters apart. So now this, from this point to this point here, is 40 meters. From the roof of the shorter building, the angle of elevation of the roof to the roof of the taller building is 43. So again, I will draw what we have here. So this one here is 40 meters. Now from the roof of the shorter building, so you will draw a line here. Horizontal line. The angle of elevation of of the angle of elevation to the roof is 23. So this is 23. And the angle of depression to the base is 48. This one here is 48 degrees. What is the height of the taller building? So again, always in geometry, because trigonometry is part of geometry, labeling the sides or the vertices of a picture will help. So I will say this is A, B, C, and D. And we'll deal with those two triangles together because the height of the taller building is BC plus CD. So the problem now is turning to knowing that AC is 40 meters. What will be BC on triangle ABC? So you deal with triangle ABC, 23 degrees. This is the opposite. This is 40. So it is tangent, that is tangent 23 is equal to BC over AC, which is BC over 40. From here, we find that BC is equal to 40 times tangent 23 degrees. Or if you use your calculator, it will be 40 times tangent 23. And it is 1697 meters. And now in triangle ACD, again, tangent of 48 degrees will be CD over AC, or will be CD over 40. And from here, CD will be 40 times tangent 48 degrees, which when you use your calculator, you will see 40 times tangent 48 is 44. 44 point, don't call that, 0.4. Okay, 0.4 meters. Now the length or the height of the tallest building, as we said, will be BC plus CD, which is 16.97 plus 44.4, and again using the calculator, 16.97 plus, in the 98 is fine, but 44.4 equal to 61.4 meters. Okay, I hope that this is a good reminder from Math 10C. If you have any question, please don't hesitate to ask. This is the end of today's lesson. Thank you.